All right, guys, welcome to Lab 16, Week 16. This is our final lab. Congratulations. After this, you will have made it through our class. All right, so we're going to be reviewing for your final that you will be having in Math 171. To reiterate, we do not have a final in this course because we are a supplement to that course. All right, so for our review, question 1, we have AutoZone operated 3,483 stores in 2004. By 2007, AutoZone operated 4,056 stores. We're going to assume the number of stores followed a linear pattern, right? Which that tells us that we're looking for a linear equation, which means our equation needs to be in y equals mx plus b form. So what I'm going to do is I'm going to first, I need to find out what I'm going to be using in my calculator. So for this very first part of data for 2004, when I go to utilize it, I'm actually going to make it my year 0. I'm not going to use 2004 because if I were to try to find my y-intercept or my 0, it would take me back to year 0. And in year 0, well, I'm pretty sure we didn't have AutoZones back in year 0. So in 2004, my year 0, we had 3,483 stores. And in 2007, we had 4,556. Well, to find 2007, I know I have to do the difference between 2007 and 2004. So this data is at 4,056. So in my calculator, I'm going to hit my stat, and I'm going to put in list 1 and list 2. And I know I'm going to put in my 0, 3, and my 3,483, 4,056. And I'm going to do stat calc, and I'm going to have it calculate a linear regression. Well, when I do this, all right, it says, A, find a model that represents the situation. Well, we know that this is a linear regression. And when we go to plug it in, or get our equation, it's going to come back as y equals, I believe our equation is 191x plus 3,483. If you were to have used 2004 and 2007, you would have gotten negative numbers, which we're not looking for. We know that this data is going up. It's increasing. The data must be positive. So our slope is 191, and it wants to know the interpretation. Well, what does this mean? Well, it means that AutoZone is building 191 stores built each year. All right, and according to the model, how many stores will AutoZone have in 2015? Well, it says to find it algebraically, meaning it wants you to do it by hand. So I'm going to have to figure out what's the difference between 2015 and 2004. Well, it's 11. So in my equation, I'm going to plug in y equals 191 times 11 plus 3,483. Plug it all into my calculator, and I'm going to get 5,584 stores will be open in 2015. Now, it says, according to the model, when will AutoZone have 10,000 stores? Again, find algebraically, which means do it by hand. Well, instead of y, I'm going to put my 10,000 equals 191, and we're looking for the year, plus 3,483. So I'm going to subtract and I'm going to put my answer to the side here. I'm going to get 6,517 is now equal to 191x. We're going to divide. Not by that x, apologies. Divide by 191. So I get x is, I get 34.12. So, but I need to know the year, so I'm going to actually have to round that. So I'm going to take my calculator, right? And I'm going to go 2004, which is our starting year. And I'm going to add Well, 34. So 2004 plus 34 years. The year will be 2000, right? We're going to use 34. And we're going to get an answer of the year 2038. We should have 10,000 stores. So remember, you're going to get that 34, but it said, when will AutoZone have 10,000 stores? Well, I need the year, the actual year. So I'm going to take it and plug it back in. All right, for number 2, we're not solving these. We are working them until we cannot anymore, and we are going to make sure that we have simplified answers. So if you remember, you're going to be taking f of x plus g of x for this first one. So I'm just going to go x squared plus 6 plus x minus 8. Well, that's easy. I'm going to get x squared. I'm going to add, let's see, plus x. 6 minus 8 is minus 2. So I'm going to get x squared plus x minus 2. For this one, I'm going to have g of x, or f of g of x. Remember, I'm actually taking this g of x and I am plugging it into f. So again, I'm taking g of x and I am plugging it into x. So I'm going to, instead of x squared, I'm going to have x minus 8 squared plus 6. Well, I have to square x minus 8, so I'm going to get x squared. That's a minus 16x plus 64. Actually, I'm going to drop that parentheses there. Plus 6, and my final answer, final simplified answer will be x squared minus 16x. 64 plus 6 is 70. All right, for 3, it says, find the requested information given our polynomial. Well, if you need to, please rewrite this in descending order, because I'm going to ask you for the degree and the lead coefficient. Well, you might want to go, oh, the lead coefficient is 2. That is not correct. That is actually a constant. I am going to rewrite this in descending order by denominator, or degree. Negative 5x to the 7th is the largest, and then I have a plus x squared minus 5x plus 2. So my degree is odd, it's 7. My lead coefficient is negative 5, which means it's going in a downward motion. The maximum number of x-intercepts I can have based on the information given, because I tell you very specifically without looking at the graph. So maximum number of x-intercepts or solutions will be 7. In behavior, okay, remember, I said that it's going in opposite directions. So it's starting at the top and it's going in a downward motion. So I know that my left side goes up, right side goes down. Y-intercept, well, of course, that's my constant. It's at 0, 2. Maximum number of turns. I take that 7 and I subtract 1 to get 6 turns. So in reality, let's see, I'm going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, something like that. Okay, so it's going to look a little rough. Now, for the maximum number of x-intercepts, again, I'm not looking at my graph. I'm going purely off of what the equation says. I know that some of those are probably going to be imaginary. All right. 4, I'm given a polynomial function that has already been factored. We're going to find all of the zeros, both real and imaginary, along with their multiplicities, and we're going to create a rough sketch of that function. So, looking at it, you know that you're going to have to take each one of these and set them equal to 0 and solve. And then obviously the multiplicities are the exponents that are on the outside of our parentheses. So very first one, I'm going to put x plus 1, set it equal to 0, x minus 3 equal to 0, x squared minus 5 equal to 0, and then x squared minus 2x plus 4 equal to 0. So solve the first one and I get -1. So I know that x is -1 with a multiplicity of 2. This next one, I will solve it to get x equals 3, but it has a multiplicity of 5. This next one, x squared minus 5, to solve it, I move the 5 over, so I get x squared equals 5. But I have to take the square root, and when I do that, it's always going to have a plus minus square root of 5. So I get a square root of 5 and a negative square root of 5. This last one, can you factor it? Well, what times what gives you 2, or gives you 4, but adds to be a -2? Nothing, because the factors are 2 and 2, or 4 and 1, and they do not add to be a -2 in any way. So I know that I'm going to have to use the negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to do that. I'm going to change my ink so we can see what I'm doing. So negative b, well, that's a negative of a -2, plus or minus the square root of b squared, so that's -2 squared, minus 4, a is 1, and c is positive 4, all over 2, a is 1. Well, -2 is a positive 2, plus or minus the square root. I can plug all of this into my calculator all at once, and I'm going to get a -12 underneath, and it's, of course, all over 2. I'm actually going to have to bring my work over here to the side. So I'm gonna rewrite this so we can see it. 2 plus or minus -12, 2a. All right, so I have to first pull out that negative, and then I have to break down that 12. That 12 becomes a 4 times 3 underneath there. So when I go to take the square root, it'll be 2 plus or minus square root of 4 is 2, so that's a 2i, with a square root of 3 remaining over, that's not 2a, sorry, that was just a 2. Each part has a 2, so I know I can pull a 2 out, and when I do that, I'm left with 1 plus or minus I with a square root of 3. So I get an answer of 1 plus I square root of 3 and 1 minus I square root of 3. Remember, these are the imaginaries. These are the ones that are not going to occur on our graph. So now I'm going to draw my lines. I know, let's see, I'm going to go over 0 occurs in the middle. I'm going to go over -1, -1, 2, 3, 4, -1, -2, -3. All right, so those square roots of 5s, well, that's just a little bit past 2. If you don't know, plug it into your calculator, see what it looks like, and you're going to see that it's actually kind of a little bit past -2. So I am going to go up. I know I'm going to bounce off of the -1 because that's what the multiplicity of a 2 tells me I'm going to do. I'm going to jump over to that 2 because that's our square root of 5. And then I'm going to kind of go a little flat at the 3 and then go up. All right, if you have to, very carefully plug it into your calculator and take a peek of it, or go to Desmos.com, plug it all in, and you will also be able to get a good representation of it on Desmos. But remember, that's just for you to take a peek and give a rough sketch. You need to show your work for every other part of this. Okay, so we are given a fraction. It says, find the requested information for this given function. So anytime we're going to be dealing with these, remember we have to factor it first. That's the very first thing I need to do. I noticed that I have a lead coefficient here, so I'm going to use my method where I multiply the first times the last. And let's see, I'm going to go over here. I'm going to start at the top. So I'm going to have an x squared plus 3x multiply first times last, and I get a -4. Well, I can do x, what gives me -4 but adds to be 3? Well, that's x minus or plus 4, x minus 1. Remember, I'm going to bring back that 2 and divide both of them by 2. So I divide, x plus 4 is divided by 2 is 2. 1 and 2 do not divide, so he comes back up. So he goes 2x minus 1. So there's my factor for the first one. Again, I'm going to start, I went up on that one, so I'm actually going to start down on this one as well, because I'm going to see, actually, no, I don't think I have to. Never mind. He's easy. What times what gives me -6 but adds to be a -1? Well, that's x plus, nope, x minus 3, x plus 2. I notice I have 2x plus 2's top and bottom, so I know that those cancel out, and I immediately know that he's my hole. So I'm going to come over here and say x plus 2 equals 0, and I know that I have a hole at x equals -2. But I need to know the other part of that hole, so I'm going to have to plug him in to my fraction. So I'm going to have 2 times -2 minus 1 over the remainder of -2 minus 3. I'm going to end up with -4 minus 1, -5 over -5, which equals a +1. So I'm going to have a hole at -2, 1 on my graph. Now, domain. I am going to use the remainder of my simplified fraction. So I know that it's going to be the denominator. So domain is denominator. So I take that x minus 3, and I'm going to use him. So I get x minus 3 is 0. I solve, and I know that x cannot be cannot be a +3. So when I go to write my domain, I know it's going to go from -infinity to 3, union 3 to infinity. Vertical asymptote. Well, if I used my denominator, let's see, I know that it cannot occur at 3, so I'm going to have a vertical asymptote at 3, meaning I'm going to have my dashed line occur at 3. The horizontal asymptote is determined by those first 2 terms in my fraction, so I'm going to have the 2x squared over what is essentially a 1x squared. Because those x squareds are the same, I'm going to use those lead coefficients of 2 over 1. So I get a horizontal asymptote at y equals 2. X-intercept. Well, that's nice and easy. I'm actually going to take and I'm going to plug in. So actually, I'm going to take the numerator for this guy. So I get 2x minus 1. Well, if I solve that, I'm going to end up getting a 1/2. And because it's the x-intercept, it's at a y equals 0. The y-intercept, well, that one's nice and easy. But the y-intercept actually is also controlled just by these last constants. So -2 over -6 is going to reduce to be a 1/3, but I'm going to put it in as a point, so 0, 1/3 is where I have a y-intercept. If all else fails, plug it into your calculator. Take a look at it. All right, for 6, finding the inverse. Remember, step 1, set it equal to y, So change f of x to y. Matter of fact, hang on. We're going to change f of x to y. Then I'm going to switch the x and the y, and then I'm going to solve for y again. So I have, instead of f of x, I'm going to have y equals x minus 1 over 5. I'm going to switch my x and my y, so this becomes x equals y minus 1 over 5. Now, remember, I have to move that 5 first because he is in the denominator. I'm going to multiply both sides by 5 to get 5x equals y minus 1. Move the 1 to get 5x plus 1 equals y, and he is my inverse. So I'm going to go back over here. I'm going to write my inverse as y to the power of negative 1 equals 5x plus 1.